Okay, so in this video we're going to talk about how to find the distance when we're dealing with things in the coordinate plane. Now, I know there's a distance formula you guys may remember from back in the day. By back in the day, I just mean from before, where it was distance equals rate times time. Distance equals rate times time. That's not what we're talking about. We're going to talk about a way to find the distance, specifically when given like coordinate grid type directions. For example, when you're working in a coordinate grid. So we're going to start by taking a look at this example right here. The whole idea is, this concept is, if I ask you to tell me how far apart was this dot and this dot, how far apart were they? Well, if you imagine a line connecting them, if I asked you that question, you'd be able to answer it. You'd be like, well, they go across 3 squares. So that means that would tell us that the distance that those two dots are from each other are 3 units. Their distance from each other is 3 units. So horizontal lines are easy. Same thing goes for vertical lines. If I'd given you that line, I said, how long is that line? Or I said, how far away are those dots, those points in time? You would tell me, okay, so that's 1, 2, 3, 4, 5. You would say 5 units. So horizontal and vertical, those lines are easy to count because they're easy to tell how long they are. You literally just count the squares. Remember, we're not counting corners. We're not saying 1, 2, 3, 4. No, that would be wrong because that'd be 1 too many. You have to count the squares. How many squares you go across? 1, 2, 3. 1, 2, 3, 4, 5. So horizontal and vertical is easy. What we're going to talk about in this section isn't horizontal and vertical, since those are easy. We're going to talk about how to find distance of diagonal routes. For example, going from here to here. So that's a diagonal route. It's not going across an even number of squares. Because when you go diagonally across a square, it's not the same distance as if you had just gone straight across one of its sides. So we're going to find a way to do that. The good news is, if you've been practicing the Pythagorean Theorem up until this point, you are already going to be able to do this. Your only new skill is going to be how to make the right triangle out of it. So here's what's going to happen. In a given question, I'm going to put it in red, a question is going to give you 2 dots, or they might give you 2 ordered pairs, like they do here. They might just give you 2 ordered pairs, and they might not give you the graph. If they don't give you the graph, make your own. So when you have those 2 dots, you sometimes they'll connect them for you, sometimes you can connect them yourself. They're going to ask you, how long is that? How far away are they from each other, those 2 endpoints? Your job is, you're going to create a right triangle by looking for an intersection of these grid lines. We have a grid line right here from that corner. We have a grid line right here from that corner, and also going downwards. So you're going to look to see where did they cross. So that's as if you'd gone upwards. This was one option. You could have gone there, or you can go in the direction that they went in. You see those cross right there. So whether you go top or bottom doesn't matter. Those are exactly the same size triangles. So I'm going to go with top since they went with bottom. I'm just going to show you. I'm going to draw that right triangle on the top. So because you stuck to the grid lines, that makes this a 90-degree angle right here. This angle is 90 degrees. So because of that, we know it's a right triangle. And because it's a right triangle, we know that we can use what we know about the Pythagorean Theorem. We can count this leg of this Pythagorean Theorem. We know it's the legs that's touching the 90-degree angle. That's 3 units. Now this leg is 1, 2, 3, 4, 5, 6. That leg is 6 units. So that means our 2 legs are 3 and 6. That now means we can find, if we find the hypotenuse of our little right triangle we just drew, the hypotenuse is the length between these 2 points, the red line. That is the length. So if we find the hypotenuse, just like we would what we were calling hypotenuse type questions, meaning finding the hypotenuse, if we treat this like that, we're going to find the length of that line. So let's go at it. A and B are 6 and 3. It doesn't matter if you get them backwards, it still gives you the same answer. So let's set this up. 6 squared plus 3 squared equals c squared. C is just going to represent the hypotenuse as usual, which is going to for us be the red line. 6 squared is 36. 3 squared is 9. C squared is just c squared. 36 plus 9, well, that's going to be 45. So we have 45 equals c squared. And now, just like all Pythagorean Theorem questions, in order to finish this, we have to take the square root. So we're going to square root both sides. Square root both sides. So the square root and the square cancel over there, and so we're left with just c. And the square root of 45, that's approximately 6.7. So I'm going to say approximately 6.7. So that tells us the length of that red line, or c, the hypotenuse of our right triangle, that length is 6.7 units. If we were talking inches, we'd say inches. If we were talking miles, we'd say miles. Whatever the case may be. So I want you to realize what we did is all these questions, since we're only talking about diagonal lines like this, we're only talking about diagonal lines such as this one. So in every question, what you're looking for, once you draw your right triangle, you're going to be looking for the hypotenuse. every question is going to be a hypotenuse type question, where you're going to draw your right triangle, as long as it's a right triangle, and you're going to count your legs, and then you're going to use those for the Pythagorean theorem. That's what you're going to do to find the distance. So that's what we're going to do. We're going to do a few more examples. Now for each of them, hit pause and write them down. Try to do them yourself first, and then hit play, see how you did. And let's see what's going on with them. All right, so now in this one, try this one on your own. Press pause and give it a shot. In case you forgot, remember it's a Pythagorean theorem, so it's a squared plus b squared equals c squared. If you need more help with the Pythagorean theorem, watch the previous video. A and b are the legs, and c is the hypotenuse. All right, so in this problem, let's imagine a right triangle coming between these 2 points. A right triangle that's with them, where this is the hypotenuse. Now, if you could go to this way, if you wanted to, and you see that they cross right here. Or you can go in the other direction. The direction you go in truly does not matter, as long as I suggest doing a direction you have room on the graph. So you can go that way or that way. You can use either or, because this right triangle right here is exactly the same size as this right triangle over here. So it doesn't matter which one you use. You'll get the exact same answer. Because I did it last time, and it doesn't really matter. I'm going to use the top one again. So I'm going to trace it out so you know which one I'm using. So now that is a right triangle. So now you're going to go to the next step of counting the legs. This leg is 1, 2, 3, 4, 5. So this leg has a length of 5. This leg is 1, 2, 3, 4, 5, 6. This leg is 6. So that means the legs of our right triangle are 5 and 6. So now it's time to use the Pythagorean theorem. 5 squared plus 6 squared equals c squared. 5 squared is 25. 6 squared is 36. C squared is just c squared. Add those together. We get 44, we get 64, okay. So, oh no, I can't count, 61, excuse me, 41, 61. Glad I thought that over again, that was gonna be embarrassing. So 61 is c squared. So now your job is to find c. Now just like last time, to get rid of a square, we're gonna have the square root both sides. So you switch to green. Square root, the square root and the square cancel, so I just put a little cross out through both of them. And now you'll notice 61 is not a perfect square, so your job is to figure out what does it equal. So 61 square root, it equals 7.810. We're going to round to the nearest tenth, so we're going to say c is approximately equal to 7.8 units. That's how long c is, well, hypotenuse, or in this case, that's how long the distance is, that's how far away this distance is between these 2 points, which means that's also the length of the line that connects them. And so that's what we just did. We just found the length of that line. It doesn't matter whether that line slants downwards or if that line slants upwards. So we're gonna try one more, and then I'm gonna show you guys an alternative method. All right, so now in this example, press pause and try this one on your own as well, and see if you can try this one and get the answer. Just now you've seen 2 examples. Press pause. Okay, because I have more room on the bottom, I'm going to go to the bottom. So I'm going to see where these intersect. When you're doing this, remember, when you go from each of these corners, you can only go up, down, or left and right. That is it, because you want to make sure where they cross, it's on the grid line, so you can ensure that it is a 90-degree angle. And if you use the grid squares given, you can guarantee that it is a 90-degree angle. So I've drawn my right triangle. Now, this leg has a length of 1. That's how long that leg is. Now this bottom leg, 1, 2, 3, 4, 5, 6, 7, has a length of 7. So that means we're going to use the Pythagorean theorem, those are our legs. So it's a squared plus b squared, which are our legs. So 7 squared plus 1 squared equals c squared. So 7 squared is 49, 1 squared is 1, c squared is just c squared. 49 plus 1, well that's 50, so it's 50 equals c squared. Now your next step is you gotta get rid of the squared. So just like always, hopefully at this point it's becoming very routine for you. You square root. That's your final step for any Pythagorean theorem question. So those cancel. Left with c equals square root of 50. Well, that's just barely bigger than 49, so it's gonna be just barely bigger than 7. So that comes out to 7.071, or approximately c equals 7.1 approximately. And so that tells us that is the distance between those dots, or it's the length of that line. That's another example of using the Pythagorean theorem in the coordinate plane to find the distance between 2 points. Now, I want to point out, in these last 3 examples you've now seen, we had examples where we were given the graph, we were given the visual. Well, sometimes you won't be given this visual. They won't do it for you. They won't give you a graph. They might not even give you anything other than they'll give you two ordered pairs. So this question could have also been asked by saying, what is the distance between the following points? So 1, 2, 3, 4, 1, 2, 3. So that's 4, 3, that point right there. That's 4, 3, and this one is -3, 2. They may have just said, find the distance between these points, -3, 2, and 4, 3. Excuse me about that. So I want you guys to realize if they don't give you the graph, but they give you the ordered pairs, you have the choice to graph it yourself and look at it visually, graph those dots, look at it and draw the line, look at this visually, and solve it that way, or you can use the method I'm going to talk about. I'm now going to talk to you about something called the distance formula. It's an algebraic way to find, it's a formula that's going to allow you to find the distance between any 2 points on any coordinate plane. That's what it's going to be for. I'm going to give you a formula that works. Now this formula always works. It works whether you have a graph or not. If you have a graph, you can use it. If you don't have a graph, you can use it. So it always works. Whereas this visual way only works when you have a graph, you have a visual. Yes, you can always take the time to draw yourself a visual. So yes, you can always take the time to draw your own graph and do it. That does work, but sometimes it might give you ugly numbers like decimals. Not that's really going to happen in middle school, but that is possible. So I want you to be aware of this other formula, that it's a possibility that you might want to consider doing for questions where you don't have a graph given for you. It might be something to consider. So what I'm going to do is I'm going to erase all this, and I'm going to use this example. Actually, I might be able to leave it, and we're going to talk about how to find it. So let's take a moment to consider what happened in this problem. We'll use this problem for a moment to make this formula, to grow this formula together. That's what we're going to do. So if you're given this question, let's pretend like we wanted to find a way to prove it algebraically, not just visually with counting. So you think of it this way. We had a left-right leg. For every question, you'll have a left-right horizontal leg, and you'll have an up-down vertical leg for every single one of these questions when you do the Pythagorean Theorem. So here's what I want you to think about. If you have a left-right leg, so if you have a left-right leg, ask yourself which variable measures left and right. And you're going to say x. Okay, so that means if we take this x value of the coordinate, so right here, this x value that dot is on, and we take this x value that dot is on, if we find the distance between these x values, since that's where those dots are, we'll have the length of the line. And you can do that algebraically by doing 4, since this is x equals 4 minus, because that's how we find the difference between things, 4 minus -3. So 4 minus -3. Think back to your negative skills in chapter 1. 4 minus -3. When you minus a negative, you end up adding. So 4 minus -3 really means 4 plus 3. Well, 4 plus 3 is 7. So that means this distance between them algebraically is 7. And that agrees with what we did visually. So what we did there just now what we did is we did the second x value minus the first x value. This is just a fancy way of saying the second x value minus the first x value. It's just letting you know it was not the same number. That's what it's telling you. So it's letting you know that they are not the same x values. It's two different x values. So if you subtract those, that'll give you the length of that leg. And now, just like the Pythagorean Theorem, that's like saying A. That's like how we found A. So we square A in the Pythagorean Theorem. So in this formula, we have to take that result we get from subtracting and square it.
Mr. Morris.
So now that we've done it for the horizontal leg, we're going to say, okay, plus b squared. Or let's plus the vertical leg. The vertical leg. The y coordinate measures the vertical. So that means if you did the second y value minus the first y value, so 3 minus 2, you're going to get a 1, which agrees with what we said here. So if you do the second y value minus the first y value, square it. Oh, I've jumped to the next step already, but if you just subtract that, that's going to give you the length of that leg. And yes, just like b squared, we're going to square it so we're squaring that leg for the Pythagorean Theorem. Now, I want to point something out. When using the distance formula, what order you subtract these in, if you get x1 or x2 or y2 and y1, if you get those backwards, it truly doesn't matter because you're going to be squaring it. So even if you got -7 here instead of +7 because you subtracted them backwards, -7 squared is 49 because -7 times -7 is +49. Well, +7 squared is also 49. So it does not matter if you have those backwards when you plug in your x values, as long as you do an x value minus an x value. So you can do x2 minus x1, and then y1 minus y2. The order really doesn't matter which way you do these. Now, just like all Pythagorean theorem questions, the last step we always do is we always end up square rooting both sides. That's the last thing we always do. So in the order of operations of our distance formula, that's also going to be the last thing you're going to do. You're going to take the square root of both sides. So now that is the complete distance formula that works for any situation.
7th grade, Victoria.
So this is a formula that works no matter what, whether you have a visual representation of your two dots, or if you're just given a question with two ordered pairs. This formula always works. So what I'm going to do is I don't want to spend too much time on this formula because this is kind of an upper level way of doing this. It's a bit of a pre-algebra, algebra 1 skill, definitely a geometry skill. But I want you to know that's what we're beating around the bush of when we're doing our visual Pythagorean theorem method. So what I'm going to do is we're going to do two problems where we're not given graphs, and we're going to do both of them. But we're going to do both of them both with the distance formula and with the visual Pythagorean theorem method. So if you prefer one method, they do both always work. But with a visual one, sometimes you have to make your own visual if they didn't give it for you. So you prefer which solution method you watch, then that can be the one that you stick with. So don't let it confuse you if you don't like one of the methods. For some people, the formula method is kind of tricky at first. But if you want to hear it again, hit rewind, listen to my explanation of how we got about that formula. I don't want you to just memorize the formula and use it. It would really give you a deeper understanding if you truly understood where it came from in terms of how we could reason out the pieces of that formula. So let's try. We're going to do two more word problems that are not giving graphs, so we have to do them on our own. Okay, so in this example, the question says, find the perimeter of triangle XYZ that has the vertices. Name of this corner is X, so XYZ, that's the name of the corner. So 0, 2, 3, -1, and -2, -3. And it says find that perimeter and round it to the nearest tenth. So what we're going to do is, you'll notice there's no graph given, there's no visual given. So in this situation, you want to make your own graph. So what I've got popping up is I've got a graph that I'm going to use to help me understand what's going on in this question. So now that you have a graph, you drew the graph paper, ruler, pencil, whatever you need. You've got your graph paper, you got your coordinate plane, now you're ready to get started. So yes, there was a way to do this question using just the distance formula, and I'll show you that in a minute. But for now, we're going to do it the visual Pythagorean theorem method first, and then I'm going to show you the distance formula. I don't want to show you the distance formula first, because sometimes that's the more confusing one we're not quite sure about yet. So I'm going to show you the one that we know first. So before we do anything, we have to graph this triangle. So corner X is at 0, 2. 0, 2, that means go nowhere left and right, but that means go up 2. So 0, 2 is right there. Now, corner Y, 3, -1, that means go to the right 3, and then go down 1. So that one's going to be right here. And so that's going to be X, and that's going to be Y. Okay, now Z is at -2, -3. That means go left 2, down 3. So left 2, down 3. 1, 2, 3. So right here. So this is going to be Z. So now that you have your three corners, you're ready. You have three corners for your triangle. So now just connect these corners and draw your sides. Use a ruler, or if you do it by hand, just keep it kind of steady. That'll be close enough. So I'm actually pretty proud. Mine came out pretty good. My students would say that's a pretty good triangle for me. All right, so you have your triangle. What we're going to do now is actually answer the question. They said find the perimeter of it. So what that means is we've got to find, you can ignore two of these sides. I'm going to kind of erase them. Look at just this side. If we do that, if we find the length of that side, pretend this was like the questions we just did, to where we literally are going to look to see where they cross. Okay, they cross right here. All right, so they cross here. So that would be one of our little right triangles to help us find the measure of it. If we do that right triangle method and we find the length of that side, what's going to happen is that is going to tell us the length of this side. So if we then do that same process for the other two sides, so this one and this one, we're going to know the length of all sides. And once we know that, once we know the length of all three sides, all we've got to do is add them together. So let's focus on just that side on the right. So I already drew the right triangle, and we see with the right triangle that we have. So now we see we have a right triangle, And we see that our right triangle is, this leg up here at the top is 3, and the leg on the right side is also 3. So we're now ready to use Pythagorean Theorem to find the length of that leg of just that triangle. So if we do that, we're going to have 3 squared plus 3 squared equals c squared. That's what we're going to have. So 3 squared is 9, so that means both of those are 9. 9 equals c squared. Add those together, that's 18. Just like everything else, your last step is to do a square root. So the square root and the square cancel. We're left with c equals, now I'm going to go ahead and round that right away just to save space on here. The square root of 18, that's a little bit bigger than 16, so it's going to be 4 point something. So the square root of 18 square root, that's 4.242. Rounding that to the nearest 10, that's going to be 4.2 is what that's going to give us. 4.2. Now you could go more precise at this step because we're not actually at our final answer, but this will be good enough to get us our answer. We'll be close enough. So that's the length of this side that is now in blue. That is the length of this side that is now in blue. We have to now just repeat that process for the other two sides. That's all we have left to do. So what I'm going to do is I'm going to come over here and I'm going to imagine a right triangle coming from these two corners. So I use dotted lines first to kind of help me see it. Nope, excuse me guys.
Yeah, now forward to the main office.
Alright, so I imagine that right triangle that goes there, and so we now see we have a right triangle here, so now let's do the exact same process. This leg has a length of 2 because we counted. This one is 1, 2, 3, 4, 5. So this one has a length of 5. So we're now ready to use the Pythagorean theorem on this triangle to find the hypotenuse of that triangle. So if we do that, that's going to be 5 squared plus 2 squared, and that's going to equal c squared. 5 squared is 25. I don't know what I'm writing up there. 5 squared is 25. 2 squared is 4. That equals c squared. Add those together. That's 29 equals c squared. Now, just like the other times, we're going to take the square root of both sides. So square root both sides, they cancel, and we're left with c approximately equals square root of 29. Well, that's just a little bit more than 25, so it's going to be 5 point something. So 29 square root, we get 5.385. Well, that's approximately 5.4. So that tells us this green side has a length of approximately 5.4 units. So this side that is now green has a length of 5.4 units. So let's take count real fast. That means we have a 4x2 side, 4.2, actually not 4x2, 4.2 unit side. We have a 5.4 unit side. Now all we gotta do is do that third and final side, and then we'll be in business. We'll actually know what it's gonna be. So now let's draw our imaginary right triangle from these two corners to that final side. Now this triangle is 2 by 1, 2, 3, 4, 5. 2 by 5. So now you'll notice this triangle is 2 by 5. Oh, well, hey, look. Our last triangle we just did was also 2 by 5. So that means the hypotenuse of this one is going to be the exact same size. So you got fortunate on this question. You don't have to actually do it 3 times. You only have to actually do it twice. All right, so since that red triangle we just draw for that bottom side was the same two units, one leg, and 5 units the other leg, that means that this length is also going to be 5.4. So we now know the lengths of our 3 sides. So to find the perimeter of this triangle, we're just going to add all of those together. So 4 plus 4 plus 2 is 10. Carry the 1. 5 plus 5 plus 5 plus 5 plus who knows. All right, so we have 15. I'm being silly. So we have 15. So now 15.0. So that tells us the perimeter of our triangle is 15. 15.0 or 15, either or. You can say 15 units. That is the perimeter of this triangle. Because you've now done the same skill we've just done in our previous 3 examples, but you had to do it 3 times for the 3 sides of this triangle. And even if it wasn't a triangle, if it was a hexagon, which is 6 sides, you'd have to do it for all 6 sides, and then you could add all 6 of them together, and then you would have the perimeter of your hexagon. So you can work with this stuff as long as you're working with the coordinate plane. This skill totally works. Now, I mentioned that I was also going to show you how to do these questions using the distance formula. So that's what I'm going to do now. So if you prefer the Pythagorean Theorem method, or the visual way of doing it, and you don't want to hear about the distance formula method of doing it, for finding the perimeter of this triangle, then what I recommend you do is you don't have to, maybe give it a glimmer, give it a glean, watch it a little bit, but if you don't think it's working for you, don't worry about it. But I am going to warn you that you're going to have to use this formula for time reasons and also for space reasons when you get to higher level mathematics. But for now, I don't mind if you're just doing it visually. So a reminder of that formula was the distance equals, and by the way, if you do this formula, it makes you look smart because you've got all these square roots, you got all these squares, you got all kinds of stuff going on here. So sometimes it can make you feel proud. It feels like you solve them with like a puzzle when you go through these. So x2 minus x1, so our change in x's squared. So just like slope, by the way, where this was the change in y, change in x, it's just like that, except when slope it was change in y over change in x. This was, it's change in x squared or change in y squared, doesn't matter which one you do first, plus the change in y squared. Then take the square root of everything. That's going to be the length of your hypotenuse, or in this case, the distance. So let's do that. Let's run through a few of these. So to find the distance between x and y, so that means the distance between these two ordered pairs up top. That means we have to find the change in x's. That means it went from 0 to 3. So if you do 3 minus 0, I'm going to write it right underneath it, 3 minus 0, and square it. 3 minus 0 is going to tell you the change. That tells you 3. So you have 3 squared. Well, 3 squared is 9. So that tells you that the change in x was 9, and is what that tells you. I'm sorry, not change in x. Change in x was 3. We squared it. That's part of the Pythagorean Theorem. Now let's plug in the other part. The change in y. It went from 2 to negative 1. So if we did negative 1 minus 2, that tells us that negative 1 minus negative 2, that's negative 3. So that's negative 3 squared is what we have over there. So negative 3 squared, negative 3 times negative 3, well that's positive 9. And that plus sign comes down. So we have 9 plus 9, still underneath the radical. Now that means we have the square root of 18 is what we're dealing with. We have the square root of 18. And so now we're ready for our answer, square root of 18. And just to piggyback on what we did earlier, we already did the math for that. We said the square root of 18 over here was 4.2. So we already know the square root of that. It's approximately 4.2. That's kind of a squiggly equal sign, kind of equal to 4.2. So that tells us the length of xy is 4.2, the length of this side. Now, if you're not able to look at this and see you've got to do these two, then these two, then these two, or the other order, doesn't matter. If you can't get that, maybe you still wanted to at least draw it, maybe not graph it, but at least draw the triangle so you can make sure that you're doing all 3 sides. So that's the distance formula for that side. So now you then do the distance formula for the next side. We'll do y and z. So we're going to do these two. I'm going to do it right next to it. So for this one, we've got to do, it went from 3 to negative 2. So if we do negative 2 minus 3, that'll tell us the change, is what that'll do. And so negative 2 minus 3, that's negative 5. So we have negative 5 squared. Now let's do the change in y's. It went from negative 1 to negative 3. So it doesn't matter if you're negative 3 minus 1 or negative 1 minus 3. It is proper to do it in a certain order, but truly it doesn't actually make a difference practically when you're calculating it. So it's not that big of a deal. So negative 3 minus 1, remember you have to square that. Negative 3 minus 1, well that's negative 4. So if you're rusting your negative skills, you might want to go back to chapter 1 to make sure you can still do these. All that's still underneath the radical. Negative 5 squared, and negative 5 times negative 5, that's positive 25. Negative 4 squared, that's positive 16. We're going to add these together, is what we're going to be doing. So now 25 plus 16, well 25 plus 6 is 31, plus another 10, that's 41. So we're dealing with the square root of 41. So now that's a little bit bigger than 36. So that's going to be a little bit bigger than what we're expecting. But I'm actually starting to think we have a mistake here because I'm looking over and I'm seeing, I remember when we did that one, we got 5.4, and this is going to be 6 point something because it's bigger than 36. So let's see if we can find our mistake. This is what I mean by checking if your answers are reasonable. Let's see if we can find that. All right, so I found my mistake. I realized where it was. I was going too fast. So it's an easy fix though. My mistake was when we did y2 minus y1, that would be negative 3 minus negative 1. I made the mistake that apparently I'm not perfect. Whenever you subtract a negative, that means you have to add. So back here where I wrote negative 3 minus 1, that wasn't actually the full thing. It was actually negative 3 minus negative 1. And that's why I mentioned why it's going to be adding. So negative 3 minus negative 1, that's the same thing as negative 3 plus 1. Well, that equals negative 2. So that's a negative 2 there. So when we square negative 2 squared is positive 4. So negative 2 squared is positive 4. So we have 25 plus 4, which means you have the square root of 29. There we go. And now that agrees with what we had over here, square root of 29. So be careful when you're doing this, because yes, you can find the wrong answer when you're doing this. So be careful with your arithmetic with adding and subtracting negatives. Okay, well, the square root of 29, now that's just a little bit bigger than 5, so it's going to be 5 point something. I'm going to go off our work we already did over here, where the square root of 29 is approximately 5.4. So square root of 29 is approximately 5.4. What you would then do is you may or may not have realized at this point when you were doing this, if you use the distance formula method, that this side was also the same size. Even if you didn't, you would do this exact same thing again and get 5.4 again. So we would now do the same thing. We would do 4.2 plus 5.4 plus 5.4, just like we did before. And we add them all together, we would get 15.0. So I wanted to show you guys that using the distance formula, you get the exact same answer. Now, judging on how long this question took, I decided I think that it's going to be best if we stop here, because I don't want to give you guys too long of a video to where it seems like a real daunting task. But we've done quite a few examples at this point. We've now done 4 examples of using the visual Pythagorean Theorem method, which I think most of you are probably going to prefer since we just freshly learned the Pythagorean Theorem. But then I also showed you the distance formula, where it came from, and we even did 2 examples of doing the distance formula for 2 different sides in this question. So this was a big question, but it allowed us to do both. So take your time when you work through these. I'm going to assume most people prefer the visual Pythagorean Theorem method. It helps to do it visually. But some of you might also like the distance formula. And I want you to be able to recognize it, because there's going to be times you're expected to use it in upper level math. And I want to make sure you can already recognize and see that the distance formula is the Pythagorean Theorem in disguise. So take your time, identify your legs, watch those negatives, especially me. Be careful with those and work your way through these. Good luck, guys.